You thinking? Leave that on record spinning. You feel the rhythm going. Legs ain't got time to lay low. Your knees are bending, so it's time to get up and let go. Hey, mama, how is it going?
Right.
Welcome.
Oh, it works. Great. So last week, we started automating the temperature and climate of my Tesla. I think this music might be a bit too loud. Let's get it down a bit. Here we go. So, is that better? Yeah, so last week we got started running an Azure function with my Tesla PowerShell module. I think we have something going, but we're not really there yet. We ended the stream with finding a bug that I solved the day after, and I'll show you what the problem was. And yep, let's get cracking. Let's see, we need to switch views. And you should be able to see my screen. And I should also, let's do this and open up the Tesla module. So hopefully I fix this and oh, my poor computer is working hard. Here we go, let's give it a second. So we had a problem last week that set Tesla temperature didn't work. It always set the lowest temperature, which obviously won't work. So I found a bug, and it's right here. So I wonder, I think I checked all this in. Come on, Git. Oh, just startup. Anyway, here I just did string format of the temperature, giving it the format string of 0:n1. N1 is like a format string to give you 1 decimal. Problem is, I'm always lazy, so I usually install my computer using English United States localization. That way I get like decimal point instead of decimal comma, and I get all like the American standards. But today or this time I reinstalled my computer. I actually did it using Swedish locality, which is a bit uncommon for me, but it's a good practice. So what happened is that I actually got a string here formatted using a decimal comma instead of a decimal point. That yeah, so that was the problem, and instead of using that, I added a get culture English United States, and that way I always get the decimal point. So that should be working now. And just to make sure that I installed that module also, we should do like this, Tesla, whoops, my Tesla, get module, and we see that we have version 101 preview, and we should be able to import Tesla context and set temperature, Tesla temperature 22. Ooh. Actually didn't test this before the stream. So I have a vehicle, it's asleep. Let's resume. Vehicle. And wait for it to wake up. There we go, it's online. Get Tesla climate state. Okay, so temperature is 21 degrees and it's actually 27.7. So we should be able to do set Tesla temperature. And that works. Okay. there might be a problem with this wake up parameter. Because if we talk to the car in less than like a certain amount of time, then it ignores the wake up because it assumes that the car is already awake. Although it might not be, because it will only be awake if we talk to something, to an endpoint that requires the car to be awake. Let's see. Yeah, so we're using this last scene. And if we haven't seen the car in more than a minute, we will get test the vehicle, which doesn't require a wake up, so that's good. And if it's asleep, we're waking it up. And once we're done, I think we're setting so here, if the vehicle is asleep, we're going to set it to wake it up here, and if it's online, we're just gonna be happy. And if we get anything else, we'll throw unknown state, and then we update the last scene because we did wake it up. Yeah, that should be working. So yeah. Should be. I'm happy. Let's close down all these. Close to right. There we go. Oh, add more. Close all. There we go. And let's go into Tesla service. So we have a Tesla service. It consists of a bunch of endpoints. I wonder if I can zoom this one. That may be a bit too much. There we go, and let's remove the console. That should be good enough for you to read, even if you're on mobile. So we have a bunch of actions, which is, well, basically small actions. It works like this. They should return something simple, like give it a start max cooling, and we'll just start max cooling and set the temperature to low and start the climate. And if both were successful, return true. We have a get charge state, get climate state, get vehicle state, start comfort climate. We just give it a temperature, and we have a start defrost, start max cooling, which is max. Start max. I think we should call this start max heating. I think it's a little bit more clear. Start max heating. Oops. Even though it says start as defrost, I think we're good. That, and we need to rename this one. There we go. That should be working. And we should also copy this and make sure we have it everywhere, because I don't really like the run.ps ones. So this one should say action get vehicle state, because when you open up a lot of them here and they all say like run.ps1, that's just confusing. So we should also rename this one. There we go. Here's another one. That should be, take this one, put it over here, and do that. Seems to be working. That looks good. We need this. Should rename this one. Whoops. Should rename this one to this.ps1. This one needs to be like that. Good. And then we have a modules folder. We probably need to replace this one because I think we have temperature. Yeah, here's the old one with the bug. So maybe we should just open up a new window, do cd my Tesla build module Semver, it's called, yeah. Let's do 1.0.1 preview 1 and yeah, that should be good enough. Oh yeah, I don't have a manifest in this folder because it's in here. There we go. So let's open up this folder. Here. There should be a bin folder and in my Tesla. Let's take out all of it probably. And browse to the Tesla service modules, my Tesla. Whatever. Paste it and replace everything. There we go. So I think we should be ready to test this again. Let's close down this one. Let's close them all. So that should be working there. So if I do func start, that should start up our function. Looking good so far. And nothing's running. Perfect. So let's see if we can get the Tesla up and running too. Alright, so here is the Tesla app on my phone. The climate is currently 26 degrees inside the cabin and it's set to 22 degrees, but not running. So the car is parked and ventilation or it's not on. Let's see, look at the code. So we have an orchestration called orchestration prepare takeoff, and this has some configuration. So we have a max cooling threshold of 20 degrees. Oh, this is gonna be funky, but let's see what happens. So we set this when we started the whole thing. If I go back here and I just click this link, that should get the function going. It didn't work at all. Error executing profile, see logs for details. Didn't find a Tesla module. That's a bit funky. So the module is here. I wonder if I have a required version or profile. Where's the profile? It's here, and we do import module by Tesla. So this should be working. Let's do this module, sorry. And this module pack. Good. Then we do equals. Oops. Quote my path modules. And then we do, sorry, this again. Before I draw my Tesla and show that. So we have it there, and we have it in the... It's weird how it resolved this one first. I was hoping it would resolve the other one. Anyway, let's remove the module. Tesla force. Clear the screen, and do one start again. So I wonder if we did something wrong. Let's remove the preview, just in case the function runtime don't like preview. It feels like it's a long shot, but you never know. Other than that, I think it looks good. Let's call this 102. Shouldn't do a difference. Let's remove this too. I wouldn't think that this is for the install module, but you never know. Let's try again. Oh, everything crazy. Thank you for following. Much appreciated. Let's try to trigger this again. Something's wrong with my module. What if I do import modules Tesla? Okay, so there's a problem with that module. Let's try that again. Oh, it's version, right? Let's remove this. Put this here. Remove that one. that's why. Sorry for the confusion. Oh, start. 30 times the charm. Here we go. Xenobytes OffSec. Thank you for following. Alright, we're running. Let's get the app running also. So here you can see that the climate is now set to temperature low, and it's on because I can turn it off. So that seems to be working. Let's scroll the output here and see what happens. So it got some status here. This is the charge state, and then it got the temperature saying the inside temperature is 25.1, and then it went down to start max cooling. So it started max cooling. Should actually bring the seat heater on, I think. No, sorry, max cool. That should not bring the seat heater on. Yeah, and then we should be in a pause. Let's look at the code. Alright, something's happening again. Awesome. We are getting climate state again. Now the temperature is 22.9 degrees. Alright, so we're inside the loop. Let's see, here we go. So this should... Here is the timer. We sleep one standard interval, which is 45 seconds. And then we get the vehicle state and the climate state. And then we check if the user is present, and if target temperature is less than 0, then we're going down. Or we're aiming to go with a difference that is below the comfort temperature. So then we're gonna look if the climate inside temperature, which is the current temperature, let's say it's 25, minus the comfort temperature, let's say that is yeah, so let's say we want 20, we got 25, then we get a temperature difference that is 4 degrees, 5 degrees, and we actually want that to be -4. Yeah, so the current temperature should be 16 degrees. If that is 16 and we subtract the comfort temperature, which is 20, we get -4, and -4, and target temperature difference is -3. We should probably have -2. I think -3 is a bit too high. So if we go to greater than or equal, I think we should be happy with. Then no, if it's greater than, if it's equal, we're not continuing. So then we start over. Okay, cool. And if temperature difference is positive, which is here, 5 degrees above, then we do the same and say if it's lesser than, we continue. If it's none of these, we set it to 0 and we invoke the start comfort climate with an input of start comfort climate, and then we measure the time passed. then write this. So that shouldn't be needed. We only do write host. See if we can set time past this. Okay, so that doesn't work. That's because I misspelled it. There we go. Goes back to this. And there should be a better way of logging this. So we have a lot of like executing information. Let's try to just copy this and do write output as well. I'm not going to do repose here anymore. I'm going to do I don't know, let's say write the host. Write stuff we don't. Good. And then if we look at so get climate state, we're only using outside temperature and inside temperature. So I'm thinking maybe I should reduce the output, because it's a lot of output to read through when I look at these logs. Every time I do this, it's like a whole bunch. I'm not sure if I need anything. I should just like select 2 or 3 things I need. Yeah, I guess that's fine for now. Yeah, so let's look at the car. It has the inside temperature of 25 and we are heating. Cool. So let's do a function start again and see what happens. There we go. Start to prepare takeoff. It was cold. We should have this. I wonder if I have like fast sounds. I don't. So let's put this one. Come on. Put this one on the left, and let's put this one on the right. Remove that, so we should be able to read what's happening. So we get more space and blow up the font. There we go. And let's put the app over here somewhere. Alright, so we're currently doing max cooling. Let's go up and see what's happening. A lot of things. This is where we started. Executing prepare takeoff. Here's the battery status. Oh, it changed. Awesome. So we're doing this, and here is the climate status. We started max cooling. reason null. I wonder if we can give it a reason. That would be cool. So a look at the... So I wonder if I can load the invoke activity function. Not sure where that is. Not here. Let's do a quick internet search. Documentation this, I hope. Here we go. Creating reference. Not much. Not very helpful. Oh well. There we go. Oh well. I wonder if I can just do like get command, invoke activity function, dash syntax. See what it says. And also I can do like get command. This. Let's turn this off. And let's try this. Oh, of course it doesn't. Get command. Let's just look at this. See if we have some good information here. We have a module property, which is EP's module info. So I should be able to do module. What is this? Module. Ah, we have a module name, but the module is empty. So what if I do module name pipe get module? No? List available. That didn't go. Let's try get module. This part with list available. Get Tesla Let. Okay, that works. Probably don't need list available because it should be imported. We should do that and do path. Awesome. This is a really hacky way to get stuff done, but yeah, if it gets the job done, it gets the job done. So let's do this. So first we get command syntax. That should just print the syntax, and then we do just get the command, which should give us the metadata of the command, and then we do get module of the module name that the command consists of, and then we output the path that should tell us where the module is, so we can invoke it ourselves later, or at least import it. There we go, and then we can do func start and see what happens. Oh yeah, I had an orchestration running, so when I restarted the function, it took up where it left. Oh. I think we can stop that and go here and say Azure. Sorry, clean won't work. Azure close. Good, closed. Now we can clean. So Azure is, oh come on, Azure clean. Azure is the storage emulator. The parent isn't working for me right now. Let's close that one out and do Tesla service. Here we go. And I think I can down dash recursive dash force. Let's close this thing down, maybe better. Good. Start a new one. So it's a storage emulator, and instead of using actual Azure storage, I'm using local storage in this folder. So it's actually really nice, but sometimes it's a bit of a hassle to reset, because whenever I start an orchestration and I abort it, it's a bit hard to make it forget about the previous run. Come on, there we go. Now it shouldn't be running, so we could do only start it, of course. Azure write start. Start the function. Wait for the Azure to start up. Right, so we should be able to clean these out. And sorry for the small text, but I will zoom and explain what it says. But we need to be a little bit small right now to be able to read the output. Let's trigger it. It says it was programmatically called, and then it starts and it says here is the utility function. It's Microsoft.something, and here is awesome. So that's the path. Code quote. Cool. And then should be able to see something here. Where were we? We need a terminal. There we go. And this one, and then this one. So we're currently running at max cooling. It's 25 degrees, and this says it gives the battery status, and then it does all this information every time. Bit of a hassle, and then we get the climate mode. It says it's 25 degrees. It start max cooling. Should have some kind of... Okay, so I don't seem to see the right host. Maybe we can see the time passed. I'm not sure what just happened to me. There we go. Okay, so I think we can conclude that right host and right output. Oh, there we go. Temperature is set to 25. That's an information, so that should be a right host. That seems to be working. The output does not seem to be working. Oh, sorry, information set temperature set to 25. That's the set temperature. That is inside of here. Actions.comfort temp. Oh, awesome. So we should probably do some logging here, like write. I'm uncertain what I want to write, but let's write output saying current temperature is something like this, and it should be here, starting on changing to comfort temperature, comfort temperature. Something like that. I haven't decided if we should use right host or right output then. When we run this for real, we're going to be able to set like a logging level, I think. And yeah, maybe I want to just don't have output and only log. We'll see. Anyway, that logs the temperature, and apparently that works. We do the start comfort temperature, and then we do get climate state a few times. Temperature sets 25. Oh, cool! It actually picks up on changes without me having to restart anything. Current temperature is 16, changing to time passed is 2 minutes, time passed is 3. We probably want that to be in minutes. Something like this. And do same here. And I suspect that the time pass doesn't work. Yeah. Let's see what happens. Oh, it does. Time passes 6 minutes. Perfect. So, oh yeah, now it's doing this thing over and over and over again. If market temperature not equals to 0, then we should do and then we just loop until timeout or user present. Okay, and let's set the time of minutes to it's 5. And time passed is 6 minutes. So 6 minutes is more than 5. And we are calling stop climate that returns true. And then we're restarting it again. Oh yeah, because the whole script runs in a loop. So, and since it's a do... Oh, and I got late to the game, what did I miss? Apart from really... Oh, there's really loud music. Sorry for that. Let's turn that down a bit. Is that better? You haven't actually missed much, Bjompen. We are tuning the durable function. I just figure out... Thank you. I just figure out that this do until loop won't work. So we will change that to a while and say while user present. Okay, so we're gonna have to change this. While not user present and time passed in minutes is lesser than timeout minutes. So this time we won't even go into the loop if we are present or we are in a timeout. And I am uncertain how we actually exit this one, but let's look at that later. Oh, look at that, it worked. So now we got to return done. After invoking action stop climate. And the climate is stopped. Awesome. And now we're totally idle. I'm so happy. Let's try this again. So it's 25 degrees in the car. I think I have a browser here with the, not that one. So here is the URL. Let's reload this. And we can see that it triggers. We get the output here. And the output here is a list of URIs where we can terminate or get status or yeah, do a bunch of stuff. I move that out again. We can see that we're running down here. And I should bring up this in full screen and bring up the app. So since the interior temperature was higher than, I think we set 20 degrees, we're going to start. So we said that the oh yeah, we should really remove these in the beginning also. This is really annoying. So let's do that. Good. So somewhere here there should be a, see, here is the battery status and here is the climate status, and it should figure out that we should be doing max cooling somewhere here. Yeah, at least it started max cooling. Now it's 19 degrees, which is, so we're going down to, I think, 17 degrees. Let's have a quick look at this. Not that one. This one. Yep, so we are setting a cooling threshold. If it's above 20, we're going to go max cooling, and then we're going to do 2 degrees below that. So hopefully we're going down to 18 degrees, which we did. Should have done. It says 15 degrees. Inside temperature is 23. Inside temperature is 15. Yeah, exactly. So when we got down to 15.7, because last time we checked here we were at 23 degrees, and then 45 seconds later we were at 15.7. So it cools pretty fast. And this is also why I want to be able to turn it off, because it cools down the car really fast and then it drains all my battery. So here we set it's 15.7, we're changing it to 25. In the real world, we're not going to change it to 25, we're going to change it to like 20. But I need to heat it up again to be able to run this like emulation again and trigger the max cooling. So we're setting it to 25, we get true back, and then we say time passed is 2 minutes, and then I wonder why we get that several times. So we're in this loop, and target temperature diff should be 0. Let's write that out too. Write host target temperature diff is target temperature diff. And we should have an else series to make sure that we don't go in there. And we do write host just running comport temp. Okay. So time passed is 2 minutes, time passed is 3 minutes, time passed is 4 minutes. Wonder why it's doing this several times. Okay, so this seems to be working. We're running this loop at least. And time pass is 5 minutes. And whenever we go to 5 minutes, we say we're done, and it returns. So that actually seems to be working. What if we set so max defrost threshold is 18? What if I go into the app and I set this to low and I cool it down below 18 degrees and then I start it again? That should heat it up until 5 degrees above 25. That's 30. I wonder if we ever get there. Maybe we should do comfort temperature of 20 and max cooling of 25. That's probably better. And that should be like 19, just to make sure. So now we should be below 19. This doesn't update too often. So let's trigger this thing again. It's gonna start it off screen. There we go. Check the app. So hopefully it should realize. So we get the battery status. We have a temperature of 16.8 degrees. It says temperature is not extreme. You just start climate different is 0. That's this one. So yeah, I'm triggering, of course, I'm triggering the defrost on the outside temperature. I wonder if that is wise. Maybe I should just use inside temperature here too. Yeah, I think so. And there should be a terminate. I wonder if that happens if I do invoke web request. Oops. Invoke web request and use this whole URI. Runtime web attack instance terminate reason text. No such API. Hmm. Okay, that didn't work. Oh yeah, it has to be a post, of course. Method post. Ta-da! Action start if was not found. No, that is correct. Because we now call it action start max heating. See that? Start up this thing again. See if it still runs. Yep. Trigger run. Oh no, it's 20 degrees. So it won't be heating. So we actually need to set this down manually to low, and that should cool it down to really cold, hopefully. Where is the terminate post URI? Request method post, and this URI. See what happens. That seems to work this time. Orchestrator was terminated, resume text. Perfect. So now nothing should be running. We should be able to start the app. It's 15 degrees, good. And then I'm going to trigger prepare takeoff. So it's increase this so you can read it. Gets the battery status, it gets the climate information. Its target temperature difference is 5. Good, and we're doing start max heating. So this should be doing max heating, and driver seat heating is on full, and we have defrost activated. Excuse me. Yeah, that looks good. And in a real world scenario, we would have like ice on the windscreen, so we would like to really heat it up. Maybe so actually if the what? First off, I want to look at this function. So here's a module that we're calling inside the functions runtime. And here is a start activity, isn't it? Activity. Okay. So this is an alias of wait durable task. Okay. Or maybe it's the opposite actually. So activity activity function. Nothing. What is this? Invoke. Oh, that's a binary. Hmm. I wonder where we find this. It should probably be this one. Where is my searcher? Searcher. Oh, wait. This is small again, but bear with me. So let's search for this thingy here. Hmm. Copy path. Look at that. So we don't want to save that, and we want to go to the terminal. See what's happening here. It's 14 degrees. Difference is 5. So it seems like it's running this several times. I need to figure out what's up with that one. We don't have a user presence, and the instant temperature is 22.5. Still no user. Temperature is 26. 26 is high above, so now we are changing to comfort temperature, which is 20, and time passes 3 minutes. It seems like we're writing this once for every. That's a bit annoying. Oh well. So this is actually all the information. That's quite handy, to be honest. So we get the target if is 5, 5, 5, and then time passes 3 minutes, 4 minutes, 5 minutes, done. Okay, yeah, I like that. So let's see if I have, yep. So we need to copy the path to this DLL into that DLL, and then we need the path to this manifest. And now we should have invoke activity function, get command, syntax. Okay, so we can give it a function name. We can give it an input object. We can give it a no wait to just spin it off. Well, that's interesting. And we can have a retry options. I wonder what that is. So we can create a new retry options. I wonder what that does. Nothing. Right, so we can give it a first retry interval, maximum number of attempts, back off coefficient. Okay, that's interesting. We don't need that, I think. See what we have. So we have a wait activity function, new durable retry options. That's probably one to create the option instead of doing the way I did. All right. Stop durable timer. Is there a start durable timer? I wonder how that works. There's no get durable timer. We need a time span. Time span from seconds by. Okay, doesn't work to run them. At least we can explore them. Oh well. I actually think we're quite happy there. So we have a function. I'm going to tweak the numbers a bit. Here we are. Let's look at this and do a summary. So we have a function. We have some configuration. Probably we should have a defrost threshold saying like if it's below 10 degrees or something. Then we do it's above 25. I probably want something like if it's above 25 is good, or 23 or something. Comfort temperature should probably be around 18 degrees. Sleep standing interval seconds 45. Yeah, I think that's good. And timeout minutes should be 30. So we get the start time and we get the charge state, and then doing this, and then we get the climate state, and then we do. I actually think we're gonna just ignore these for now because we're not using them. So if it's lesser than defrost threshold, we should probably call this max heating threshold. Threshold with a capital M. There we go. And then if it's lower than max heating threshold, we're going to start max heating. Else if it's greater than max cooling threshold, we're going to start max cooling. Makes sense. And I want to make sure we actually turned off the seat heating. Yeah, that works. And otherwise, we're just gonna say nothing is extreme. Let's start the comfort temperature. And then we're gonna loop and say unless the user is present, we should probably set this somewhere. Yeah, we need to test if this works sometime. But basically we get these states, and oh, here we're actually starting a durable timer, but we're not doing anything with it. Oh yeah, this is probably a... This is the weight. We don't have a weight durable timer, we only have a start durable timer. So that is probably the weight task. So that's the sleep. Probably do that the first thing we do. And we're going to do write host saying waiting for seconds. And then temperature difference is set to, and then we get the vehicle state and the climate state and the user presence. And user presence, present. Something like that. And then we say if the temperature difference is less than 0, means we are cooling down. Otherwise we are defrosting. This should probably just be null. We're going to skip that one. I'm going to do host of that. I think I like that the most. Whoops. Save. No output. Good. And we're just going to ignore that too. I actually think we're not done, but we have a good start. Yeah. So next time we're either going to deploy this to an actual Azure function, or we'll start to learn how to program my microcomputers. I wonder where I have my computer. I think it's here somewhere in the mess that is my desk. Maybe not. I misplaced it somewhere. Oh well. I have a what's it called? Yeah, it's like a mini computer. It's this big, and it's running Yeah, it's called Node MCU, I think. It's an ESP32 device. So it's this tiny little thingy. And I'm planning to have it connected to my Wi-Fi and have a button on it. And when I press the button, it's going to start this. So hopefully we can get cracking on some hardware soon. And I might be doing that in MicroPython. And I've never done that before. So that's going to be interesting. Anyway, thank you so much for hanging out with me today. I had a great time, and I'm quite happy actually. I think this is a good start. And next time we'll either build some Azure Functions infrastructure, or we'll try to get started on some MicroPython and actual hardware. That is interesting. All right, thank you very much, and see you next week. Bye bye.